Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Chapter 1, Computer System Organization, Part 3, for the Class 11 students of Computer Science. In this video, we are going to cover the topics software concepts, types of software, system software, operating system, language translator or processor, application software, general purpose application software, specific purpose application software. So let's dive in and get started. Let's discuss about the software concepts. A computer system can be considered to be made up of two main components: hardware and software. Hardware means all the physical devices such as monitor, mouse, keyboard, and CPU that you can touch and feel constitute the hardware components. However, hardware alone cannot perform any task until it is given some instructions. Software is a set of programs and related data that are used to give instructions to the hardware. In other words, software directs and guides the operations, input, process, output of a computer system. The games you play on a computer, the music and video files that you listen to and see on a computer, the documents on which you work, and most importantly, the operating system environment in which you work on your computer system make up the software components. Here you should know about the term software piracy, which is the unauthorized copying or distribution of copyrighted software. We should always use licensed software. Now we can see the types of software, that is the classification of computer software. Look at this chart and follow along with me. I have numbered the types of software in red color as 1, 2, 3, and 4. Software is divided into four main types: system software, application software, utility software, and programming tools. Number 1. System software is further divided into operating system and language translators. Further, the language processor is divided into compiler, interpreter, and assembler. Number 2. The application software is further divided into general purpose and customized software. Number 3. Utility software is further divided into disk defragmenter, antivirus software, and backup utility. And number 4. We discuss about the programming tools. Now we discuss about the system software. The system software is required to control the overall operations of a computer system. System software refers to a type of computer software that is designed to manage and control the hardware resources of a computer system. It provides a platform for other software applications to run on, and performs important functions such as managing memory, processing input and output, managing files and data, and providing security and protection against malware and other threats. Functions of system software. It reads data and receives information. It translates data and instructions. It controls all the peripheral devices. It processes and generates output. System software can be classified into two categories: operating system and language translators. System software is further divided into operating system and language translators. Here we can discuss about the operating system. An operating system, OS, is the most important software without which you cannot work on a computer system. It is the most basic software that is present in a computer. It serves as an interface between the user and the hardware. It manages the resources of a computer system, including hardware, software, and network resources. Now you can understand this definition. An operating system is an integrated set of specialized programs that is used to manage the overall operations of a computer. It acts like an interface between the user, computer hardware, and software. Here are the functions of an operating system. The first function is the resource management. The operating system, OS, manages the computer's hardware resources such as CPU, memory, input or output devices, and storage. It allocates resources to different applications and ensures that they are used efficiently. The second function is the process management. The operating system manages the processes, which are instances of running programs. It schedules the processes, allocates resources to them, and provides inter-process communication. The third function is the memory management. The OS manages the computer's memory, ensuring that applications have access to the memory they need while preventing them from accessing each other's memory. The fourth function is the file management. The OS manages files and directories, providing a file system that allows users to organize and access their data. The fifth function is the security. The OS provides security features to protect the system against unauthorized access, malware, and other threats. It controls access to files and system resources and provides authentication and encryption. The sixth function of the operating system is the device management. The OS manages device drivers, which are software programs that enable communication between the operating system and hardware devices such as printers, scanners, and graphics cards. The seventh function of the operating system is the user interface. The operating system OS provides a user interface, allowing users to interact with the computer through menus, icons, and windows. It enables users to run applications, manage files and folders, and customize settings. The eighth function of the operating system is the networking. The OS provides networking capabilities, allowing the computer to connect to other computers and devices over a network. It provides an environment in which computer hardware components are used in an efficient manner. Let's see some examples of operating system, OS. Microsoft Windows, Mac OS, Linux, Android, and iOS. What is an operating system user interface? The user interface, UI, of an operating system, OS, is the means by which a user interacts with the computer system. The UI provides a way for the user to interact with the operating system and the software applications running on it. There are several types of user interfaces used in modern operating systems. Let's see one by one. The first type of user interface is the command line interface, CLI. This is a text-based interface that allows the user to interact with the operating system by typing commands into a terminal or command prompt. The second type of user interface is the graphical user interface, GUI. This is a visual interface that uses windows, icons, and menus to allow the user to interact with the operating system and software applications. GUIs are the most common type of interface used in modern operating systems. The third type of user interface is the touchscreen interface. This is a user interface that is designed to be used with touch screens, such as those found on smartphones and tablets. The interface is optimized for touch-based input and allows the user to interact with the system by tapping, swiping, and pinching. The fourth type of user interface is the voice-activated interface. This is a user interface that allows the user to interact with the system using voice commands. This type of interface is commonly used in virtual assistants and other voice-activated applications. The fifth type of user interface is the gesture-based interface. This is a user interface that allows users to interact with a device or computer system by making physical gestures with their hands or body, instead of using a traditional input device such as a keyboard or mouse. Gesture-based interfaces are becoming more common in modern operating systems, particularly on mobile devices and touchscreen-enabled devices. The use of gesture-based interfaces has been popularized by devices such as smartphones and tablets, which use touchscreens to detect gestures such as tapping, swiping, and pinching. Now let's see some common examples of gestures used in gesture-based interfaces. Swipe. A gesture used to move content left or right, or up and down. Pinch. A gesture used to zoom in or out on an image or content. Tap. A gesture used to select an item or initiate an action. Flick. A gesture used to quickly scroll through content or move it in a specific direction. Now, in this types of software chart, we have learnt about the operating system under system software. Now we are going to learn language translators and the subdivisions of compiler, interpreter, and assembler. Here we can discuss about the language translators. Software are created by writing programs in computer languages. There are many computer languages such as C, C++, Java, and Python, etc. A program written in any high-level programming language, or written in assembly language, is called the source program or source code. The programs written in these languages cannot be understood by a computer directly. Why? We have already learnt that a computer is an electronic machine and can only understand the machine language, which comprises zeros and ones. So, a language translator or language processor is needed, which is a very important software as it translates or converts a program written in a computer language into the machine language so that it can be understood by a computer. Let's see some types of language translators. First one is the natural language processing (NLP) software. Some examples of NLP software include spaCy, NLTK, Natural Language Toolkit, Stanford NLP, and Amazon Comprehend. These tools can be used for tasks such as sentiment analysis, named entity recognition, and text classification. The next one is the speech recognition software. Popular examples of speech recognition software include Amazon Alexa, Google Assistant, Apple Siri, and Microsoft Cortana. These virtual assistants are used to perform tasks such as playing music, answering questions, and controlling smart home devices. The next one is the machine translation software. Some examples of machine translation software include Google Translate, Microsoft Translator, DeepL Translator, and Yandex Translate. These tools can be used to translate text from one language to another. The next one is the chatbots. Chatbots are computer programs that use language processing to interact with users in natural language. Some popular chatbot platforms include IBM Watson Assistant, Microsoft Bot Framework, and Dialogflow. The language processors can be of three types: assembler, compiler, and interpreter. Let's learn about the assembler in detail. Assembler is a type of programming language used to write low-level software programs that can be directly executed by a computer's CPU. Each statement in an assembler language corresponds to a machine-level instruction that the CPU can understand and execute. Assembler code is often used to write low-level software such as device drivers and operating system kernels. Assembler language is sometimes referred to as assembly language, and it is typically specific to a particular CPU architecture. Assembler programs are usually written using a text editor. Assembler programs must be translated, assembled, into machine code before they can be executed. Assembler programs can be more difficult to write and maintain than programs written in higher-level languages, but they can be faster and more efficient because they execute directly on the CPU. The second type of language processor is the compiler. A compiler is a type of computer program that translates source code written in a high-level programming language into machine code that can be executed by a computer's CPU. Unlike assemblers, compilers work at a higher level of abstraction, translating entire programs rather than individual instructions. Here are some key points about compilers. A compiler is a software tool that takes in source code written in a high-level programming language and produces executable machine code. The machine code produced by a compiler is specific to the target CPU architecture and can be executed directly by the computer's CPU. Compilers typically perform several stages of analysis and optimization on the source code before generating machine code, which can result in faster and more efficient programs. Compiled programs can be distributed as standalone executable files, which can be run on any computer with a compatible CPU architecture and operating system. Compilers are often used to write high-performance software such as system-level programs, games, and scientific simulations. Common examples of compilers include GCC, GNU Compiler Collection, Clang, and Microsoft Visual C++. The third type of language translators is the interpreter. An interpreter is a type of computer program that directly executes source code written in a high-level programming language, without first translating it into machine code. Interpreters work by reading and executing one statement at a time, rather than compiling an entire program into machine code before execution. Here are some key points about interpreters. An interpreter is a software tool that directly executes source code written in a high-level programming language. Interpreters typically work by reading and executing one statement at a time, rather than compiling an entire program into machine code before execution. Because an interpreter executes code directly, it can provide immediate feedback on syntax errors and other issues, making it a useful tool for learning and debugging. Interpreted programs can be slower and less efficient than compiled programs because each statement must be interpreted at runtime, rather than being compiled into machine code beforehand. Interpreters are often used for scripting and rapid prototyping, as well as for languages that are designed to be interpreted, such as JavaScript and Python. Common examples of interpreters include the Python interpreter, the Ruby interpreter, and the JavaScript engine used in web browsers. Now let's discuss on the difference between compiler and interpreter. While both compilers and interpreters are used to translate high-level programming languages into machine code that can be executed by a computer's CPU, there are some key differences between the two. First point. A compiler reads the whole program at a time, whereas an interpreter reads the program line by line. Second point. A compiler translates the whole program at a time into machine code, whereas an interpreter translates only one line of program at a time into machine code. Third point. A compiler produces machine code which is directly understood by computer, whereas an interpreter produces intermediate code after translation. Fourth point. A compiler takes large amount of time to analyze the source code, whereas an interpreter takes less amount of time to analyze the source code. Fifth point. A compiler is faster than an interpreter. Sixth point. A compiler requires more memory space, whereas an interpreter requires less memory space. Seventh point. A compiler is good for professionals, whereas an interpreter is good for beginners. Eighth point. A compiler reports all the errors in the program along with line numbers. When all the errors are rectified, the program is recompiled, and after that the compiler is no longer needed in the memory. Whereas an interpreter displays errors while translating a program into machine language. It cannot execute a program until all the errors are resolved. Ninth point. Programming languages like C, C++ uses compiler. Programming languages like Python, Ruby uses interpreter. Now, in this types of software chart, we have learnt completely about the system software. Next, we are going to learn about the application software and the subdivisions, general purpose and customized software. The second type of software is the application software. An application software is a set of programs designed to help users perform specific tasks. They may be installed on a computer depending upon the user requirements. Different application software are available to serve different purposes. The application software can further be divided into two categories: general-purpose application software and specific-purpose application software. First, we will discuss about the general-purpose application software. General-purpose application software are developed keeping in mind the general needs and requirements of a large number of people. Some examples of such software are word processing software. This type of software is used for creating text-based documents such as letters, stories, and reports. All word processing software provide options for creating, editing, formatting, and printing text and graphics in a document. Examples of word processing software are Microsoft Word. Microsoft Word is one of the most popular word processing software programs in the world. It is part of the Microsoft Office suite of programs and is available on both Windows and Mac operating systems. Microsoft Word is known for its user-friendly interface, extensive formatting options, and collaboration tools. Examples of word processing software include Google Docs. Google Docs is a cloud-based word processing software developed by Google. It is free to use and is accessible through any web browser. Google Docs includes real-time collaboration tools, which allow multiple users to work on a document simultaneously, and it automatically saves changes as you make them. Next is the Apple Pages. Apple Pages is a word processing software developed by Apple. It is available on Mac and iOS operating systems and is known for its intuitive interface and professional-looking templates. Next is the LibreOffice Writer. LibreOffice Writer is a free, open-source word processing software that is available on Windows, Mac, and Linux operating systems. It includes a wide range of formatting options and can open and save documents in a variety of file formats. Next, we are going to discuss about spreadsheet software. This software accepts data values in row and column format to allow users to manipulate, calculate, and analyze data in the desired manner. Examples of spreadsheet software are Microsoft Excel. Microsoft Excel is one of the most popular spreadsheet software programs in the world. It is part of the Microsoft Office suite of programs and is available on both Windows and Mac operating systems. Excel is known for its powerful calculation and data analysis features, as well as its extensive formatting options. Next spreadsheet software is the Google Sheets. Google Sheets is a cloud-based spreadsheet software developed by Google. It is free to use and is accessible through any web browser. Google Sheets includes real-time collaboration tools, which allow multiple users to work on a spreadsheet simultaneously, and it automatically saves changes as you make them. Next spreadsheet software is the Apple Numbers. Apple Numbers is a spreadsheet software developed by Apple. It is available on Mac and iOS operating systems and is known for its intuitive interface and professional-looking templates. Next spreadsheet software is the LibreOffice Calc. LibreOffice Calc is a free, open-source spreadsheet software that is available on Windows, Mac, and Linux operating systems. It includes a wide range of calculation and data analysis functions, and can open and save spreadsheets in a variety of file formats. Now, we are going to discuss about DBMS, which means Database Management System. DBMS is a software program that lets you store a large amount of data in an organized manner. A DBMS can store details about the customers, employees, products, students, etc. For example, Oracle, Microsoft, Access, FoxPro, OpenOffice.org base, etc. What is Oracle Database? Oracle Database is a relational database management system, DBMS, that is widely used in enterprise applications. It is known for its scalability, reliability, and security features. What is MySQL? MySQL is an open-source relational DBMS that is used by many web-based applications. It is known for its ease of use and flexibility. Next database management system is the Microsoft SQL Server. Microsoft SQL Server is a relational DBMS that is used primarily in Windows-based applications. It is known for its performance, scalability, and security features. Now we can discuss about the DTP, which means Desktop Publishing Software. This software is used for creating designs and layouts of books, journals, brochures, newspapers, etc. DTP software provides users with tools for designing layouts, formatting text, adding images and graphics, and creating templates. Examples of DTP are Adobe InDesign. Adobe InDesign is a professional-level DTP software that is widely used in the publishing industry. It provides users with a wide range of tools for layout and design, including text and image formatting, page layout, and the ability to create interactive documents. Next DTP is QuarkXPress. QuarkXPress is a DTP software that is similar to InDesign. It provides users with tools for layout, typography, and image editing, and is often used in the publishing industry. Next desktop publishing software is Microsoft Publisher. Publisher is a desktop software that is designed for small businesses and home users. It provides users with a simple, user-friendly interface for creating documents such as brochures, flyers, and newsletters. Next desktop publishing software is Scribus. Scribus is a free, open-source desktop software that is available for Windows, Mac, and Linux. It provides users with tools for layout, typography, and image editing, and is often used by small businesses and non-profit organizations. Now, we can discuss about the graphics software. This type of software allows you to create and edit and manipulate digital images and graphics. Graphics software is widely used in fields such as graphic design, digital art, web design, and photography, among others. Examples of graphics software are Adobe Photoshop. Photoshop is a professional-level image editing software that is widely used in the graphic design and photography industries. It provides users with a wide range of tools for editing and manipulating images, including tools for cropping, resizing, retouching, and color correction. Next graphics software is the Adobe Illustrator. Illustrator is a vector graphics editor that is often used in the graphic design industry for creating logos, illustrations, and other graphics. It provides users with tools for creating and editing vector graphics, such as paths, shapes, and lines. Next graphics software is the CorelDRAW. CorelDRAW is a vector graphics editor that is similar to Illustrator. It provides users with tools for creating and editing vector graphics, as well as tools for layout and design. Next graphics software is the GIMP. GIMP, New Image Manipulation Program, is a free, open-source image editing software that is available for Windows, Mac, and Linux. It provides users with a wide range of tools for editing and manipulating images, including tools for cropping, resizing, and color correction. Next graphics software is the Canva. Canva is a web-based graphics design software that is designed for non-designers. It provides users with a simple, user-friendly interface for creating graphics such as social media posts, flyers, and presentations. Next general-purpose application software is the multimedia software. This software lets you combine images, text, sound, animations, and videos to create interactive applications. Example Adobe Director and Adobe Flash. Next general-purpose application software is the presentation software. This software application is used to create and design slideshows and multimedia presentations. Example Microsoft PowerPoint. Now we can discuss about the second application software, specific purpose application software or customized software. Specific purpose application software is developed keeping in mind the specific requirements of an organization or an individual. Software designed specially to achieve specific tasks are also known as customized software. Example: reservation system used at airports and railway stations, payroll system used by organizations, stock, inventory control, system used by organizations, banking system, financial accounting, inventory management software, billing system used at supermarkets, etc. Now, in this types of software chart, we have learned completely about the system software and application software. Next, we are going to learn about the utility software and programming tools in the next video. Chapter 1, Computer System Organization, Part 4. Thanks for watching. Watch the upcoming videos. Chapter 1, Computer System Organization, Part 4, which includes types of software, utility software, disk defragmenter, antivirus software, backup utility, compression utility, disk cleaner, device drivers and programming tools. You can check the link in the description box below.